of the day. In this video, we are going to talk about working with Azure Search. This is from the last module of Azure Certification 203 or AZ-204, and really interesting topic because no one care about it, and people don't focus on it, and sometimes they lose some points because of this. So I would really encourage you to pay attention to this video, and if you haven't watched my previous videos, please watch them as well. These videos are not dependent on each other, so you can watch those videos later on, and I hope it will help you to clear your Azure certifications. So let's get started. In this module, we will talk about creating a Microsoft Azure Search Index, full text search in Azure Search. So and indexing and querying documents. So let's get started. Lesson first, creating an Azure Search Index. In this lesson, we will cover Azure Search, create Azure Search Service, create Azure Search Index, indexing and indexing documents, and querying an index. What is Azure Search? Azure Search is a search as a service cloud solution that gives developers API and tools for adding a rich search experience over private heterogeneous content in web, mobile, and enterprise applications. So query execution is over a user-defined index. Build a search corpus containing only your data, sourced from multiple content type and platforms. Let me just create it a laser pointer so that you know what we are talking about. Leverage AI-powered indexing to extract text and features from image files and entities and key phrases from raw text. Very interesting. Create intuitive search experiences with facet navigation and filters, synonyms, autocompletes, and text analysis for "Did you mean so?" autocorrected search terms, which is really good for your web applications. Let's say if someone is searching for something and generally they don't find answers because the question was not formatted as you wanted, so and your system is not smart, so they are not human being. You can formulate a question in many ways, and you might not have answer for that, so your Azure Search can help you with that. You can add also Geo Search for find near me, language analyzers for non-English, full text search, and scoring logic for search rank. So functionality is exposed through a simple representational state transfer, so application REST API or .NET SDK that masks the internet complexity of information retrieval. In addition to APIs, Microsoft Azure Portal provides administration and content management support with tools for prototyping and querying your indexes. Because the service runs in cloud, infrastructure and availability are managed by Microsoft. So you have full availability. So what you can do with Azure Search Index? You can provision the Azure Search service in Azure Portal or through the Azure Resource Manager API. Before you can upload searchable content, you must first define an Azure Search Index. After you define an index, you are ready to upload content. You can use push or pull model. After populating an index, you can issue search queries to your service endpoint by using simple HTTP requests with the REST API or .NET SDK. So what you do: provision service resource, create index, import data in the index, and perform search operations. So to create search Azure Search service. How to use Azure Search? Step 1. Provision service. You can provision an Azure Search service in Azure portal or through the Azure Resource Manager Management API. You can choose either the free service shared with other subscribers or paid tier that dedicates resources used only by your service. For paid tiers, you can scale a service in two dimensions. And then once you have provisioned service, then you need to create index. We saw here. The second step was to create index. So to create index, before you can upload searchable content, you must first define an Azure search index. An index is like a database table that holds your data and can accept search queries. You define an index schema to map to reflect the structure of the documents you wish to search, similar to fields in database. A schema can be created in Azure portal or programmatically by using the .NET SDK or REST API. Then the third step will be load data. So once you have defined your index, you can pull the data and pull the model, retrieve data and external from the external data source. It can be anything. Indexers are available for Azure Cosmos DB, Azure SQL Database, Azure Blob Storage, SQL Server hosted in Azure VM. You can configure an indexer for on-demand and or scheduled data requests. Then the fourth is perform search options. So after populating an index, you can issue search queries to your service endpoints by using simple HTTP requests with REST API or .NET SDK. So these are the features built: full text search and text analysis, data integration, linguistic analytics, geo search, user experience features such as search suggestions, synonyms, faceted navigation, filters, hit highlighting, sorting, paging, and then most important, relevance. So demo. In this demo, we should create a new Azure Search Service instance, create a new index with a few sample fields, manually upload a JSON document to the new index, use the Search Explorer to test the index. So distribution of Azure Search over disparate geographical locations is a challenge. When it comes to creating an Azure Search service for geographically distributed workloads, users who are far from data centers that is hosting Azure Search will have higher latency rates. One mitigation is to provision multiple search services in regions that are closer to the users. So that's why you can create multiple same service in multiple regions. So Azure Search doesn't currently provide an automated method of geo-replicating Azure Search Index across regions. If you are already using an indexer or on one search service, you can configure a second indexer on a second search service to use the same data source object, pulling data from the same location. Each service in each region has its own indexer and target index. So you pull data from the same data source, but then you can define your own search and indexes. So you see, you have your own indexer search, and then you in the web, and your customer can access it from any region and will have low latency. Using Azure Traffic Manager. With two or more indexes available in two or more regions, a user is routed to the Azure Search service that provides the lowest latency. Azure Traffic Manager enables you to route search requests to multiple geographically located web apps that are then backed by multiple Azure Search services. One advantage of Traffic Manager is that it can probe Azure Search to ensure that it is available and route users to alternate search services in the event of downtime. So Azure Traffic Manager can help you with that. So you see, it can then you can use the routing of Traffic Manager simply depending on your location. Service keys, obtaining service keys. So now that you have provisioned an Azure search service, you are almost ready to issue requests against your service endpoint using the .NET SDK. First, you will need to obtain one of the admin API keys that was generated for the search service you provisioned. So for this, you have to find your service API key, sign into Azure portal, go to Azure Azure Search Service plate, and select the keys icon. You have directly keys icon there, and then you can get them. Search service key types. To find your service API key, you can get them. Once you have them, then your search service has admin keys and query keys. So you have two types of keys: admin keys and query keys. Query keys are only for performing searches and read documents, but admin keys are to create indexes, manage accounts, read documents, perform search. So now let's do the real stuff, indexing and querying documents. So creating an Azure Search client by using .NET. You see here you have a service name, we get it. Then you use the admin API key, which we just got them from here. And then you create a search service client using your search service name, which was this one, and then search credential, which was admin, using the admin API key. Simple, right? So now you have your search service client. Once you have your search service client, you can use it to query, index, or do other stuff. In Azure Search, an index is persistent store of documents and other constructs that is used for filtered and full text search in an Azure Search service. Conceptually, a document is a single unit of searchable data in your index. For example, an e-commerce retailer might have a document for each item it sells. A news organization might have a document of each article, and so on. So mapping these concepts to more familiar database equivalent in a index is occupational, conceptually like a table, and documents are roughly equivalent to rows in a table. Create search index. So index composition includes field collection that define the searchable data in your index. Altogether, the field collection specifies the structure of documents that you upload separately. A fields collection includes required and optional fields named and typed with the index attributes that determine how the field can be used. Although you can add new fields at any time, existing field definitions are locked in for the lifetime of the index. For this reason, developers typically use the portal for creating simple indexes, testing ideas, or using portal pages to look up a setting. So you see here, each field contains a name type. Each field is configured with a specific attribute, and only specific fields like the keys are required. create an Azure Search index. To be continued. So field attributes, then you have a searchable, full text searchable subject to lexical analysis such as word breaking. During indexing, if you set a searchable field to value like sunny day, internally it will be split into the individual tokens sunny and day. So this is lexical analysis with the combining two words. Filterable, which is like to filter with the specific words like sunny, day. Then you have sortable. Then you want to be you want the search to be filtered, sorted with more relevant options. Facetable, typically used in presentation of AI search results that include hit count by category. So how many hit count are there? Then retrievable determines whether the feed can be returned in search results. So to create an index by using .NET. So first you create a definition, which means new index. You say example index. You can name it anything. Then you have the fields. In the field you create its list of fields. So you create a new field, ID of the field, type, is a key, is sortable, is retrievable. So you see you can give all these attributes here. So you see is a key, is sortable, is retrievable. All of them are true here. It's the same way you can ask for other fields. And then you just create service client. Service client is the one we created earlier here. If you remember, we created this service client using the admin API key. So now we can use that service client and add indexes and create using this definition. So we are creating an index. Create an index by using .NET classes. So then you have a .NET class, let's say document. Here we created separately and giving the values like this, but same way we can also use a specific .NET class and then put the the attributes here. Key is sortable, is searchable, is sortable, is facetable, is sortable. So you see here I'm just putting the attributes and these will be translated into these variables. So create an index by using .NET classes the same way. Definition, new index, name, example index, fields, field builder, field type of document, and you just create it. So very short, right? Not like this one, very big and repetitive. So indexing documents. Documents to import data into your index by using the Azure Search .NET SDK, you will need to create an instance of the search index client class. You can construct this instance yourself, but it's easier if you already have a search service client instance to call its index.get client method. And then search index client has a documents property. This property provides all the methods you need to add, modify, delete, or query documents in your index. Indexing documents by using code. So in typical search application, index management and population is handled by separate components from search queries. Like indexes.get clients is convenient for populating an index because it saves you the trouble of providing another search credentials. It does this by passing the admin key that you use to create the search service client to the new search index client. However, in part of application that execute queries, is better to create such index client directly so that you can pass a query key instead of an admin key. So, and also you should not use admin key all the time. To import data by using .NET SDK, you will need to package up your data into index batch object, and in an index batch encapsulate a collection of index action objects, each of which contains a document and a property that tells Azure Search what action to perform on that document. So like upload, merge, delete, or other options. So you see here is search index client, then index client equals to search service client dot indexes dot get client stack with the name of the example index. Indexing documents by using code. So now once you have the indexes, then you can have index action with type of document which you upload. New document, you see, upload the list of documents, and then you index batch dot new action. So in this index batch you add these new actions. Indexing documents by using the REST API. So then you can also index them by using the API. So you have this search service which you created, and then search.windows.net indexes example index docs index blah blah blah, and then the version of the API, content type application JSON, and API key you should send the admin key. So you see here you just replace the search service with your search service, and that's all. Indexing documents by using REST API. So then you need to send these values as well. So value are like search action upload, search action delete, search action merge or upload, and then you need to send the ID, name, blah blah blah, hotel ID, blah blah, all those things. Just pay attention here, the data type is not fixed here. So here it's ID, name, department. Here you only send action and then hotel ID. Here you send different, so data type is different. Querying an index. And in Azure Search, a query is full specification of a round trip operation. Parameters on the request provide match criteria for finding documents in an index, execution instructions for the engine, and directives for shaping the response. A query request is a rich construct specifying which fields are in scope, how to search which field to return, whether to sort or filter, and so forth is unspecified. A query runs against all searchable fields as full text search operation, returning an unscored results set in arbitrary order. So you have to be a bit smart. Azure Search get query by using the APIs. So here then you have simply index design and query design are tightly coupled in Azure Search. An essential fact to know upfront is that index schema with attributes on each field determines the kind of query you can build. Index attributes on a field set the allowed operations, whether a field is searchable in the index, retrievable in results, sortable, filterable in, and so forth. Azure Search post query by using this REST API. So same way you have your search API demo or whatever your name of the search API, then same search.windows.net indexes products docs blah blah, and then you send your query. So search test top 10, skip 10, count true, skip 50, order by product ID, and facet. So you just send your query like this, and your response will be uh, filtered. So it will be filtered with test top uh, 10 with skipping 50. You see this thing. So query string parameters. Here you see many query string parameters: count, order, facet, and these things are really specific. So API version, the version of the API you would like to use for your request. And then search is the actual text based query, search query to return all the documents. You can use the wildcard star operator. You can use either the built-in simple query syntax or the newer loosened query syntax with this parameter. Facet used when you would like to return faceted metadata about a specific fields in your result set. Search mode, whether you want to match on all words in the query or any word in the query, so you can say search mode. You have OData query string parameters. You have count, you have skip, stop, order by, select, filter. I think these are self-explanatory, so I don't need to talk about them. Querying an index by using .NET. So you have search the entire index for the term budget and return only the hotel name field. So you see here, we just created a hotel name to select equals to new hotel name, and this is we are creating search parameters, and then document search result type of hotel with index client which we created dot document, and then search a type of hotel with budget, and budget is the thing we just created for the term. So you see we are just applying filters and then getting the queried result. Querying an index using .NET. So after the filter, you can also have filter base rate 1T and 150. So these are the specific things you specified in your index. Really specific to your data type. Query syntax, simple syntax. So you can have these logical operators as well, and or not, suffix, phrase, and then simple syntax is default. Invocation is only necessary if you are resetting the syntax from full to simple. To explicitly set the syntax, use the query type search parameter. Valid values include simple or full, with simple as default and full for loosen. Query syntax for the loosen syntax. So here you see the same way, cat index hotel blah blah blah, and same way post, and then you specify here, you specified information technology, and you see search category NX, and you see, pay attention here, slash information technology and search mode all. So you see here, and then API version and query type full. Create an Azure Search indexer. So an indexer in Azure Search is crawler that extracts searchable data and metadata from the external Azure data source and populates an index based on field-to-field mappings between the index and your data source. This approach is sometimes referred to as pull mode because the service pulls data in without you having to write any code that pushes data to an index. So you just pull the data and do extract it. So these are the type of crawlers Azure Search indexes are based on data source types or platforms with individual indexers for SQL Server on Azure, Cosmos DB, Azure Tables, Storage or Blob Storage, among others. And then you can use an indexer as the sole means for data ingestions, or use a combination of techniques that include the use of an indexer for loading just some of the fields in your index. You can run indexers on demand or on recurring data refresh schedule that runs on as often as every 15 minutes or 30 minutes, whatever. So it can be created by using the Azure portal or REST API. So these are the steps to create an Azure search indexer. So you need to, these are create a data source, and indexer pulls the data from the data source. Then you create an index. An indexer will automate some tasks related to data ingestion, but creating an index is generally not one of them. As a prerequisite, you must have a predefined index with fields that match those in your external data source. Then you create and schedule the indexer. Indexer definition is construct specifying the index and data source and schedule. An indexer can reference a data source from another service as long as that data source is from the same subscription. So let's do full text search in Azure Search. Full text search, lexical analysis, document retrieval and scoring. In this lesson, these are the main topics. So full text search. For text queries, Azure Search will seamlessly deliver expected results in most scenarios, but occasionally you might get a result that seems off somehow. In these situations, having a background in the four stages of Lucene query execution, query parsing, lexical analysis, document matching, and scoring can help you identify specific changes to query parameters or index configuration that will deliver the desired outcome. So these four Lucene query parameters: query parsing, lexical analysis, document matching, and scoring. Azure Search uses Lucene for full text search, but Lucene integration is not exhaustive. So these four things can be used to get the full text search and the desired outcome. Processing a full text search query starts with parsing the query text to extract search terms. The search engine uses an index to retrieve documents with matching terms. Individual query terms are sometimes broken down and reconstituted into new forms to search more broadly for what could be considered as potential match. So let's say like sunny day, those were the two words. So if you just read sunny and if you were looking for sunny day, the match is different and the context can be different, and you can find somewhere day, but that's not the exact match you were looking for. Query parsing. You have three terms: term query, phrase query, and prefix query. Term query is like spacious, you see here. Prefix query like air condition. Phrase query is like ocean view. So you should and must have. So operators associated with the subquery determines whether the query must be or should be satisfied for a document to be considered a match. For example, ocean view is must due to the plus operator. So you see here, search spacious air conditioner star and then plus. You see plus, you put plus here, and that means must be. So you search for should be a spacious air condition, spacious and air condition, and then you say ocean view. And the lexical analysis, lexical analyzers process term queries and phrase queries after the query tree is structured. And an analyzer accepts the text inputs given to it by the parser, processes the text, and then sends back tokenized terms to be incorporated into the query tree. The most common form of lexical analysis is linguistic analysis that transforms query terms based on rules specific to given languages, reducing a query term to the root form of a word, removing non-essential words, stop words such as the, or, and in English, like breaking the composite word into component parts, converting the lowercase to uppercase, these type of things. As I already talked about sunny day. So sunny day together makes a different meaning than the sunny and day separately. Document retrieval. So document retrieval refers to finding documents with matching terms in the index. During query execution, individual queries are executed against the searchable fields independently. The term query spacious matches document one like Cosmos, Contours or suits here. You see, then you have these numbering here. Then you have prefix query and then phrase query. In the whole, for the query in question, the document that matches are 1, 2, 3. 1, 2, 3. Not this fourth one. 4. No. Scoring. And then you can also add on top of a lexical analysis, lexical analysis, query parsing. You can also add scoring. So after that, once you have, like, every document in search result is assigned a relevance score. The function of the relevance score is to rank higher those documents that best answer a user question as expressed by the search query. The score is computed based on statistical properties of terms that matched. At the core of the scoring formula is TF by IDF, term frequency divided by inverse document frequency. So like here, values search score 0.256 blah 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 blah, contests or suites. So, and description, spacious room, ocean view, walking distance to the beach. Same way, comfortable air conditioned rooms with ocean view. This is matching with more with ocean view, but you see it's giving only 0.89 because comfortable, not spacious, air conditioned. Yes. Same way, you see here score cliff adjacent on the north shore of the island. This is totally different, not including any of these words, and also you see 0.05. So the lexical analysis helps you to get that. So to review here, we created an Azure index, not created but talked about indexing and querying documents, full text search in Azure Search. I hope you really like this video, and if you did, then please like, share and subscribe and support this channel so that it can be promoted by YouTube. It helps in YouTube algorithm to promote the channel. If you are looking for Azure certifications videos, then please don't forget to watch other videos in the playlist AZ-203 or AZ-204. Thank you for watching. Have a nice day. Bye. See you soon.